V2RV, VU2 TFF, VU2 Juliet Oscar.
Excellent copy. Your new Slim Jim antenna is doing a good job. As far as I'm concerned, I'm getting you 5D plus. So anybody copying MJJ repeater will be getting you 5D plus.
A repeater is a combination of a receiver and a transmitter that receives signals and retransmits it so as to cover a longer distance. Usually, repeaters are located at high elevations so that two stations located at lower elevations can communicate with each other through the repeater at longer distances. Most of the repeaters are for VHF and UHF frequencies, while there are some repeaters for 10 meter and some for higher frequencies. In my region, all the repeaters are for VHF, while there are a few UHF repeaters in other regions of the country. Usual communication on VHF, UHF and higher frequencies are limited by line of sight. Hence, repeaters are needed for long distance communications on these frequencies. As an example, I am able to communicate easily through VU2 MJJ repeater all the way from Kasaragod, about 180 kilometers north, to Kottayam, which is about 200 kilometers to the south. Without the repeater, maximum distance I can contact is usually about 20 kilometers, though sometimes it might be possible to work up to about 40 kilometers. VU2 MJJ repeater is at about 30 kilometers from my location, situated on a hill, so that people in my region are able to access it even with a small handheld radio. So, with the help of VU2 MJJ repeater, someone in my region using a handheld radio could contact even in a radius of 200 km of the repeater. That is about terrestrial repeaters. Repeaters can also be onboard satellites. The crossband repeater on International Space Station is located at an altitude of about 400 km, and it is possible to contact over thousands of kilometers using it. I have personally contacted one near New Delhi at a distance of around 2000 km. If you think of the repeater on board the geostationary amateur radio satellite Qatar Oscar 100, the range is much more, as it is located at around 36,000 km altitude. Person from Brazil can contact someone in Thailand, as the footprint of the satellite is quite large. But these require much higher setup and not just a handheld radio, as in case of local VHF repeaters. Coming to 10 meter repeaters which work on HF, one person in Germany has worked large number of countries with a 3-watt radio and a vertical antenna sitting on the balcony of his home, as he had a 10 meter repeater nearby. There is also one VU ham who has been able to access 10 meter repeater in Australia and have a few contacts through it with a directional antenna. But most amateur radio operators are confined to terrestrial VHF or UHF repeaters on those bands. Repeater Book gives a global list of amateur radio repeaters in a region-wise manner, which is easy to locate. Frequencies and other details needed for access are also available on that site. A terrestrial repeater works on two frequencies, mostly on the same band. Satellite repeaters are usually cross-band, like the amateur radio on International Space Station, which receives in VHF and transmits on UHF. These are called the uplink and downlink frequencies. In case of a typical terrestrial repeater like VU2 MJJ in my region, it receives on 144.850 MHz and transmits on 145.450 MHz. The difference in frequency is known as a negative shift of 600 kHz. Some repeaters may have a positive shift like VU2 RFF, which has a positive shift of 600 kHz. UHF repeaters and higher band repeaters naturally have higher shifts. This is the push to talk or PTT button on the mic. When I press the PTT, the frequency changes to 144.850 MHz. Crossband repeater on International Space Station has uplink on 145.990 MHz and downlink on 437.800 MHz. Qatar Oscar 100 has uplink on 2.4 GHz and downlink on 10 GHz band. The difference in frequencies is needed because the repeater receiver and transmitter work at the same time. So, in order to prevent the transmitted signal from overloading the receiver, significant difference in frequency is needed. Duplexers are typically used for amateur radio repeaters. They separate transmit and receive frequencies of the repeater based on the direction of the signal. Usual amateur radio repeaters work in a single amateur radio band like 2 meter or 70 centimeter with only a small separation between the transmitted and received signals compared to the crossband transponders of the amateur radio satellites. As an example, a typical VHF repeater has only 600 kHz spacing between the transmitted and received signals. At the same time, the transponder of ARISS receives uplink on 145.990 MHz and transmits downlink on 437.800 MHz, which is quite a wide separation compared to a VHF repeater. Hence, the duplexer for a repeater is a large structure known as cavity duplexer. Such a large structure is needed to isolate the two signals within the same band. As in the case of amateur radio satellite operations, two antennas at a spacing are also used sometimes with repeaters to avoid the use of a large cavity duplexer. This could be sometimes due to the lack of availability of an appropriate cavity duplexer or because of undue signal loss in a cavity duplexer. Basic components of a repeater system include antenna, feed line, receiver, transmitter, duplexer, and control system. Patching systems are in place when other services like phone patching or connection with Echolink, DMR, D-Star, All-Star, etc. are needed. As mentioned earlier, antenna and feed line can be single or separate for the transmitter and receiver. Repeater output may be in the range of plus 50 dBm, decibel milliwatt, while the repeater needs to receive a signal in the range of minus 110 dBm. dBm is power level expressed in decibels relative to a milliwatt. 30 dBm will be 1 watt, while 20 dBm will be 100 milliwatts, and plus 50 dBm 100 watts. So there is a difference of 160 dB between the transmitter and receiver, which is huge. Antenna used for repeaters need to be high performance, omnidirectional, durable and efficient. They are placed either on a high tower or the highest structure possible. Good antenna systems could cost as much as some radios, even excluding feed line, but they can perform well for decades if properly installed and maintained. The feed line for a repeater is better implemented with a hard line rather than a simple coaxial cable. Hard line, as the name implies, is more like a pipe with a central conductor than like the usual flexible coaxial cable which we routinely use for amateur radio operations. As they are stiff, They are difficult to work with and naturally more expensive. But the signal loss is much less for a hard line compared to a standard coaxial cable. This is needed because we have to receive weak signals as well as send the transmitted high power up to the antenna, which may be quite high. Hardline being more durable reduces the difficulty of repeated tower climbs to replace it. Repeater controller is a small computer which is programmed to control the repeater. It can announce the repeater call sign periodically using CW or voice. It can be used to interface the repeater with other facilities to which repeater signals can be patched as discussed earlier. Remote access to the repeater controller is possible in modern repeaters to enable and disable CTCSS, Continuous Tone Coded Squelch System, or PL, Private Line Tone Access.